Hey everyone, my name is Vlad, I'm software developer at Project Zero. Today I will show you how to stream real-time swap events on Uniswap V3 using Project Zero's block functions. If you ever worked with blockchain data, you know how difficult it can be. Blockchain is decentralized and transparent, but getting useful data, it is a challenge. Raw data is unstructured, transactions are encoded, and filtering out the right events might take a lot of time and work. For example, let's say you're building a DeFi analytics tool, an arbitrage bot, or tracking swap activities for on-chain monitoring. You need real-time data, but retrieving it directly from the blockchain is a slow, complex, and expensive process. Let me show you why. Here I prepared a little diagram for you to showcase what is required in order to extract blockchain data if you want to do it yourself. And first of all, you need a blockchain node. It can be self-hosted copy of a node in your infrastructure, or you can use an external RPC data provider. And once you get it, in order to have real-time data, you need to implement a constant polling where you, like on occasional manner, checking the node for new data or subscribing to the WebSocket if it's supported. But you have to think about the rate limiting and cost. And sometimes those requests might be unreliable and you need some retrial mechanism because we can't fully trust that at every point in time the server will be responsive. The second thing is the data consistency check. So it's not only the data to be downloaded from the node, but also we need to check if the chain is consistent, if each next block has a parent in our memory, and if the data is complete, it includes all the transactions and all the traces and all the blocks, they all are canonical. And yeah, it's the same for historical and real-time data. And also there is one interesting tricky part is the chain reorganization handling. As you might know, in order to build a blockchain chain, many miners are competing with each other in order to be included into the canonical chain. And sometimes, especially in real time, block might be processed, but due to the chain organization, it might be orphaned and no more relevant, and you have to roll back and resend it again. So that's like a tricky moment that you have to handle yourself, and it happens a lot, and you need the mechanism for it. And the another thing is backfilling data. In order to, if you need not only the real-time data, but also the historical one, you have to download all the data, and it takes a lot of time. For example, for Ethereum, there is like more than 20 million blocks. It might take 1 day or 2 days in order to download the whole history of transactions in this blockchain. And you have to store it somewhere, and you have to compress this data, and you have to effectively extract this data at any moment you need it, and you have to index this data, effectively searching for specific information there. It's a lot of work, as I said. And the next step, if you need some extract insights like Uniswap V3 swaps, so you have to extract the transactions, you have to decode the smart contracts logs, you have to filter out irrelevant transactions, and only then you have this data, you can structure it, and you got it. And on top of that, you can build some knowledge graph and use it whatever it is. But as you can see, there is like a lot of work to be done in order to have consistent, reliable data source that provides you with trusted and clear, consistent blockchain data. And all of this takes time, resources, and effort, slowing down development process and making real-time insights hard to achieve. Now let's see how we can do it all of this instantly using Project Zero. With Project Zero, we can stream Uniswap V3 swap events in real time without handling any infrastructure. And here we are at the platform, And let's set up a stream. So let's give it a name or leave it the default one. Select the network, as Uniswap V3 is running on many blockchains. And let's select the Arbitrum one, for example. And let's take a look at the latest block. Yeah, here it's a huge number. So actually roll back a little bit behind for 1,000 blocks, for example. And the stream ends never, so never ending stream. Nice. Next step is select the dataset. For Uniswap V3 swap events, we need logs and only logs. So let's select logs, batch size, leave it as it is. We don't need the delay and the block functions. Now, before we add our code, let's talk about the block functions and why they matter. Block functions is a small customizable JavaScript functions that process blockchain data in real time. Instead of writing the backend code to filter, decode, transform the data, you just simply write down the JavaScript code on our platform and we run it on our side. We don't worry about the security. We run it in the isolated sandbox with high performance, filtering and transforming the data before being delivered to a destination. And just for demonstration, I prepared some simple block functions. And here is the functions that actually filter out all the logs that coming to it, extract only Uniswap V3 pool creation and swaps events, transform it and make it to some structure and send it to the destination. And here is a final data structure in JSON where we have a block number, hash, the collection of pool creations in this block, the same for swap events in this block. Let's get to the top. For this we need the contract ABI for pool creation events, for swap events. We need hashes of their topics. We can easily get this data on either scans, they never change. In order to filter out those logs that we don't need and leave only pool creations and swaps. Some decode logic, we have here the ABI from Ethereum libraries that decode logs. We do it for pool creation and swaps. And some mapping here, we're changing some JavaScript basic transformation. And finally, we got our results in the form of JSON. So let's test it against some latest block. And here's like the output looks like, where we have block number, hash, we have an array of swaps with their pool address, who is the sender, who is receiver, how much out, how much in, some additional information about where this swap is happening, on which tick, the liquidity size, and some additional information, etc. And yeah. With that, you just provide us with the code. We run it in this isolated environment, and here we are. So let me create the stream. For the destination, as you can see, we support currently 4 destinations, and for them I will select the webhook. In this section, we handle the chain organization. As I already told you that in blockchain, chain organizations sometimes might happen, and we have to deal with that. We either ignore it, we choose none, or we might resend it, like block has been reorged and we resend it again, or roll back and resend, where we pushing to the webhook that this block has been rolled back to the root of the organization, and then send the blocks again. Let's leave it just a resend. Destination URL, I prepared some destination URL, and I don't need the compression for now, and I guess we can create the stream. Okay, and here is my destination URL. As you can see, the stream is running and I'm getting some data here. That is nice. It's pretty fast. You see, is how fast we getting the blocks. It's all the blocks with data. It's real data. You can see here the block numbers, the hash, all the swaps that happened in this block. As in other blocks, so actually we're getting not just we're getting it in the batch of tens blocks, and here you can see like all this swap information, and it's, as you can see, each message is the next 10 blocks, and we're getting a lot of data pretty fast. Let's see, here we have a nice diagram, how fast we are, how much block have we sent, what is the progress now, we are in real time. And yeah, I guess we good, we get this data on our destination URL. Yeah, nice, perfect. Now let's talk about the use cases. Why it's useful. Here are some examples of real-world applications where we can utilize streaming Uniswap V3 swaps. Arbitrage bots detect price difference across DEXs in real time, or MEV strategies identify profitable front-running and back-running opportunities. Market making adjust liquidity provisioning dynamically based on the swap volumes. Or on-chain risk monitoring, prevent price manipulation or track whale activities. Or simply wallet notifications, get real-time alerts when specific tokens on specific wallets are swapped, or some liquidity migrated, or some specific trader is making some deal. And instead of building the entire infrastructure from scratch, Project Zero gives you this data instantly. It's just a few lines of code, it's just a matter of a minute, you get this data on your desired destination. So, and if you're building the DeFi and need a real-time swap data, try out Project Zero today. It simplifies blockchain data streaming so you can focus on building, not data wrangling. Sign up for now and start streaming blockchain data in a minute. If you have any questions, drop them in the comments or check out our documentation. Thank you for watching and see you in the next one. Bye.